This time we will continue with the method of variation of constants to solve differential equations second order differential equations. Okay, so there is someone wants to join us. Now we are 6, so we begin the lesson. I will give you a brief summary on how we use the method of how to apply the method of variation of constants to solve a second order differential equation. So the first step is we have our equation is written in this form. So we have u double prime plus some function of t or x. Sorry, we will put this function as a function of x as always times y plus another function q of x y prime times y is equal to some function g of x. Okay, so in this case this is a second order differential equation which is non-homogeneous. Okay, so the first step is let us first the complementary solution YH, the homogeneous solution. Firstly, we have to solve this equation. We have this is the first step. We have to solve the homogeneous equation, that is y double prime plus py prime plus qy is equal to 0. Then after solving this using of course the characteristic sorry, not necessarily the characteristic equation if of course p and q are constants. Then after solving this equation you will get something like this. You will get the homogeneous solution. There is someone who wants to join us. Okay, we continue. So the general solution, the homogeneous solution would be yh of t, which is c1 times y1 of t, of x plus c2 times y2 of x. The next step is, after doing this, we will vary the constants c1 and c2. The idea is to replace c1 and c2 with some functions u1 and u2. Okay, we assume a particular solution that takes this form. So assume the particular solution yp takes the form y of p is equal to some function u1 of x times y1 of x plus u2 of x times y2 of x. So here this replaces the constant c1, and this u2 this function u2 of x replaces the constant c2. This is why we called it the variation of constants. So now to find this particular solution, we have to solve, we need two conditions, because since we have two unknowns, which are the function u1 and u2, we need a system of equations of a system of two equations. So the first equation is that the first thing, the yp should satisfy the, so here yp should satisfy our equation y double prime py prime plus qy is equal to g of x, of course. And the second condition, which is necessary here, is that we put that we must get that u1 prime times u1 plus u2 prime times u2 is equal to 0. This condition, we impose it because it will help us simplify the calculations. You will see why. Is there any questions till now? So we continue. Now we will solve the system. So as you can see, we consider the first step, yp satisfy the equation. So here, if you replace yp, what you get, of course, you will have something like this: u1 plus u2 double prime plus p u1 y1 plus u2 prime plus q, the function u1 y1 and u2 y2 is equal to the function g of x. Okay, now you will compute, since we have the multiplication of two functions here, we use the derivative of the multiplication of two functions that we know. So we begin by we compute this first guy here, and then we move to the second y. So this is 1 and this is 2. So 1 is equal to, if you apply the rules of differentiation, you will get u1 prime y1 plus u2 prime y2. Then we let u1 and differentiate y1 plus u2 plus y2 prime. Now we remember our condition, which is this one. This implies that the first guy here must equal to 0. Okay, so 1 will be equal to u1 y1 prime plus u2 y2 prime. Okay, now we move to the second one. The second one is equal simply to 1 prime. So we will take the derivative of this guy. Again, it will be equal to y1 prime plus u2 prime y2 prime plus now y1 y1 double prime plus y2 u2 y2 double prime. So now you replace we replace in our uh, we replace back in our equation what we get. So if you replace, remember what you will get. So we have uh, 2 plus 1 plus this guy here, q times u1 y1 plus u2 y2. Okay, so this is actually equal to we have, so you have y1, I will rewrite it down here. So how to do it? So let's do it. Sorry, here we have times plus p times y1. Okay, so what you get? You will get something like this: y1 u1 prime prime plus u2 prime y2 prime plus y1 u double prime plus u2 y2 double prime plus now p times this guy here y1 u1 prime plus y2 u2 y2 prime. Okay, plus q times y1 u1 prime, sorry, u2 y2 prime. So remember since y1 and y2 are solutions to the equation, remember that remember that this since I have to change the color. So this guy and this guy here and this guy times p, this guy times p, this guy times q. So if you so this we have there, you have this term here, it rests as it is. So you have y1 prime prime plus y2 prime y2 prime plus, now we change the color, you have these guys, I will assemble them. So u1 double prime plus this p here, p times u1 y1 prime plus this guy here, which is q times u1 y1 prime. Okay, remember that this and then the second one I will change to another color, which is this one, u1, sorry, u2, this is not a good color. So next you have u2 y2 double prime plus p u2 y2 prime plus q u2 y2 prime. Now I have to remind you with something. Actually this is a solution to the homogeneous equation. So this is equal to 0, and this guy also is a solution to the homogeneous equation, so it is also equal to 0. Do you understand why? Do you understand why? Because, let me remind you, if you factor u2 here, it becomes something like this: u2 y2 double prime plus p y2 prime plus q y, sorry, here we don't have prime, this is a mistake, I have to delete this, so this we don't have prime here. So y2, okay, and we know this is a solution to the homogeneous equation, so this is equal to 0. Same thing for the others. So what remains is this guy here, okay, and we know since yp y of p, where we since the particular solution satisfies this is actually equal, so yp double prime plus pyp double prime plus qyp is equal to g of x, okay, because it is a particular solution. And now, so this guy here is equal to that one. So when we substitute, we get that u1 prime uy1 prime plus u2 prime u2 prime is equal to g of x, okay, and this is the second equation we need to solve. Okay, now let's summarize everything together. So now let's set up the system of equations to be solved. So the system is, let's move to a new page. So we have the system of two equations is, the first one is y1 u1 prime y1 u1 prime y1 plus u2 prime y1 y2 is equal to 0, okay, and the second one that we just find is u1 prime y1 prime plus u2 prime y2 prime is equal to g of x, okay. So if we solve this system of equations, then it is done. We find our particular solution, okay. So how to solve this? Actually, you studied this this in algebra, and it is called the method for solving a linear algebraic equations. We use the Kramer rule, okay. So we will use Kramer's rule to solve these equations. So we use Kramer's rule to solve this system of equations. So now let's remind you